So how do we verify identities? Here's some steps that outlined for us. Number one, work on one side of the equation. It is usually better to start with the more complex side, as it is easier to simplify than to build. So that's principle number one. Principle number two, look for opportunities to factor expressions, square a binomial, or add fractions. Principle number three, noting which functions are in the final expression, look for opportunities to use the identities to make the proper substitutions. So in other words, if you see sines and cosines on the other side, then that's your goal, and try to modify your expressions into sines and cosines. Number four, if these steps do not yield the desired result, try converting all terms to sines and cosines. All right, let's try. Example, verify that tangent theta cosine theta equals sine theta. So we're going to start with our left side, which is tangent theta times cosine theta. So what can I do? I'm gonna recall my quotient identity, and I'm gonna rewrite tangent as a sine of a cosine, and I'm multiplying by the cosine. Remember, we can turn cosine into a fraction by adding 1 in the denominator. So, and we can cancel over the multiplication sign. So cosine, the factor in the numerator, cancels the factor in the denominator. So we're left with sine theta over 1, which is just sine theta. So we finished this now looks like the right side. So we're done. Proven. I want you to try this problem by yourself and see if you can prove it. And pause the video here if you'd like, and then we're gonna move on to the next example. Next example, verify that the following equivalency using the even odd identities. Okay, so again, we have the left side of the equation and the right side, which is way less complicated. So we're going to start with the left side. It's 1 plus sine x times 1 plus, and I'm gonna actually right away use the odd function identity. So I know since we have a negative inside, so that changes, that negative travels on the outside. So instead of the plus, I'm going to have minus sine x. Okay. So what do we have now? Well, it looks like we have a difference of squares, right? 1 plus sine x, 1 minus sine x. That's our difference of squares formula. If you don't remember those factoring formulas, multiplying binomials formulas, please review them. Okay, so we have 1 squared minus sine x squared, which is basically 1 minus sine squared x. But what is 1 minus sine squared? Well, according to Pythagorean identity, that's going to be cosine square x, which is exactly our right side. So we're done. We're done verifying the identity. Let's try one more. This is example 4 in your notes, and it says verify identity secant squared theta minus 1 divided by secant squared theta equals sine squared theta. Well, this one is not very obvious, just like the ones that we did so far. Sorry about my voice. So, okay, what we're gonna do, we're gonna start with the left side of the inequality, which is secant square theta minus 1 divided by secant square theta. Okay, so I just want to tell you right away that in simplifying expression is not a very straightforward process. It's not like when you start it, you already know how it's gonna end. No, not like that. So basically, you try different things that you think you see that they might work. You apply different identities, and sometimes it doesn't work. Sometimes you have to go back and try something different. This is a trial and error, and this is okay. Like if you don't see how to tackle a certain identity right away, that's normal. There's nothing wrong with you. You're on the right track, but you need to go back and try something different if you didn't get any results with the strategy that you chose. And then also, please check your work and make sure that you didn't make any arithmetic errors somewhere along the lines. Okay, so the way I'm gonna tackle this one, I'm gonna use my reciprocal identities, and I'm gonna rewrite secant as 1 over cosine. So I'm gonna have 1 over cosine squared theta minus 1 in the numerator, and 1 over cosine squared theta in the denominator, right? So this now is a complex fraction, and I don't like the look of it. So I'm gonna rewrite it as 1 over cosine squared theta minus 1 divided by, remember, the fraction bar is just a division symbol, so I can always rewrite it like this. Okay, so now dividing by a fraction is the same as multiplying by its reciprocal, right? So I'm going to apply it here. I have 1 over cosine squared theta minus 1 times cosine squared theta over 1. So now I can actually go ahead and multiply this in, distribute this cosine square theta over 1. All right. So as you probably see already, that cosine square theta and cosine square theta on the top and the bottom cancel each other. And we're gonna just have 1 here. And now what do we have here? This is just a cosine square theta, right? It's cosine square theta. So what is the 1 minus cosine square theta? Well, Pythagorean identities tells us it's a sine square theta, and that's exactly right side of our identities. So we are done. Now, I want you to stop the video here and try to simplify to prove this identity: cotangent theta divided by cosecant theta equals cosine theta. And I'm going to see you in the next video.